Okay, so this video is going to cover average value of a function and how we use the integral process to find the average y value. So in your table of contents, go ahead and put that in your table of contents. Standard is I4 because we're really just using the fundamental theorem of calculus. It's a formula, we're plugging into the formula, but the process itself still comes down to the fundamental theorem of calculus. And then this is page 169 of the notes that you got today in class. Target says students will find, it really should say students will apply. Let's correct that first. Not will find and apply. We'll apply the average value formula for integration using the fundamental theorem of calculus and in some cases Riemann sums to determine the average value of a function. Okay, so there's really two averages that we care about in calculus. One, the average rate of change, and the average value. Now, how we find that is dependent on kind of what we're given, but if we think about rate of change and average rate of change, we've been doing that since day one. Let me get a pen here. And the average rate of change comes back to the rate of change or the slope that you've been finding since Algebra 1. And that's just our basic slope formula. Given an interval from A to B, remember both of those are x values, we use that formula m, let's not start that again, equals our slope formula, which is our y2 minus our y1. Remember, that's just formal mathematics to say y2 minus y1 over x2 minus x1. So when we find the average rate of change, okay, that's the key, that the average rate of change, we're using our slope formula. So kind of the way we do when we estimate a derivative, we go back to where we started, which was with our slope formula. Now when we find the average rate of change of a function, what we're really doing is finding the slope of our secant line. Okay. However, when we talk about finding the average value of a function, that's a little bit different because we're no longer talking about a rate of change, we're talking about an actual value of a function. So when we talk about average value, we're talking about the average y value. Now we have a set formula. We use a bar to represent average, so it looks like this, f bar. That's read the average of f of x. That is very sloppy. So the average value, or the average y value of a given function, is going to be equal to the integral, well, 1 over, b minus a. I have no idea why it keeps skipping today. It doesn't want to work. It's still on Christmas break. So 1 over b minus a, integral from a to b of what we're trying to find the average of. And this is really just the average of whatever's here, and in this case, the average of f of x. Now, f of x can represent a whole bunch of different things, like f of x can represent velocity, it can represent the rate at which rain is falling, it could represent the amount of rain that's fallen, so we can find the average of whatever it is the function that we're integrating represents. So if we think about a function x squared plus 1, and we graph that function on that graph that's right there, well, that's just a basic parabola. Get an even thinner pen for graphing purposes. That's just a average parabola that's raised up one from the vertex on the origin. So our vertex is now there. And then if we use our step pattern, or use what we remember from Algebra 2, we get some points to kind of help us graph. So those points right there. This isn't the best parabola I've ever drawn in my life. Okay, so just bear with me. Now, if we talk about the rate of change specifically to the interval that we're looking at, so -1 to 2, if we think about that point right there on our function and that point right there, when we find the average rate of change, what we're doing is we're finding, if I can get a line there, we're finding the slope of that line. Okay, and we just go back to what we learned in Algebra 1 and Algebra 2 and again in pre-cal about finding slope. And we find slope just using, we can use rise over run, we can use our formula. I'm going to use a formula because that's what I like. So M here, our average rate of change is our slope, is our f of 2 minus our f of -1 over our 2 minus -1. So looking from the graph, we can either take the 2 and plug it into our equation to get 5, or we can look off our graph at -1, we're equal to 2. And then of course over 3, this gives us 3 over 3, which gives us 1. Okay. And that value represents the slope of that line right there. Okay. Now the average value of a function is a little bit differently. It goes back to that formula. If you read the book, you would have seen how that formula was created. It talks about the proof of that formula itself, and it comes back down to what we learned from derivatives and the mean value theorem from derivatives. Okay, but let's talk about how we get it. We're going to do it first, and then we're going to talk about what that means graphically. It's kind of pretty interesting. So if we think about the interval from -1 to 2, to find the average y value, we're just going to plug it into the formula where this, of course, is a. I think I need to calibrate the pen. And this, of course, is b. So we're just going and plugging into the formula. It's just something like our slope formula. 1 over a, or b minus a, the integral from a to b of the function that we're dealing with. So in this case, x squared plus 1 dx. Now doing this is very similar to what we've been doing with fundamental theorem of calculus. All we're going to do is take the antiderivative and plug it in. The biggest difference there is the 1 over 2 minus -1 that's at the beginning. Okay, so I'm just going to simplify that, and that comes out to 1/3. Then I'm going to take my antiderivative. Remember that coefficient just kind of follows along with the process. It's the same as when we did substitution. So just bring it along. It's just an added coefficient in this formula. Okay, so when we take the integral of x squared plus 1, we get 1/3 x cubed plus x. And we're going to evaluate that from -1 to 2. So applying the fundamental theorem of calculus right there. Next step in our fundamental theorem says to take our top limit and plug it in, minus parentheses, remember that's really crucial, taking our bottom limit and plugging in. And moving on to my graph. After this, all we're doing is calculations really quickly. So that 1/3, this 1/3 from our problem is a result of that formula right there. Okay, that's all it is. Okay, now the 1/3 inside the parentheses is the result of taking the antiderivative, so don't get those two things confused. So bringing it down, just following the process until I need that. If I do the calculations, I'm going to get 8 over 3 plus 2, and then when I distribute that negative, I'm going to get a positive 1/3 and a plus 1. This is going to simplify down to 1/3 If I add all those up together, those fractions are nice and give us a total of 6. And then if I divide that, simplify that, I get 2. So this represents the average value of x on that particular interval. So if we think about the average value, remember this is a y value. So really, I'm going to go and graph that y value. Well, the first thing I'm going to do is, let's go from -1 to 2. That was terrible writing. And that's 2 right there. And I'm just going to draw a horizontal line at that average value of 2. So 1, 2. What this does is it finds kind of the value in the middle, the average value. And if we think about the area of that rectangle versus the area of the region that we're talking about, which is just this region right here, that value actually splits this region to give us an over approximation and an under approximation. Let me get a different color. So an under approximation and an over approximation that happen to be equal. Kind of gives the middle of our region, our area region. It's kind of neat that it does that. Okay, so really it's nothing different than what we've been doing with the exception of that 1 over b minus a at the beginning. And that finds us the average. Okay, so let's do 2 examples together, and then tomorrow in class we'll finish up the back of this page. Okay, really I just want you to get the idea of finding the average value. Okay, so we have an interval 0 to pi, makes sense because we're dealing with trig here. If I want to find the average value of f of x, all I'm going to do is plug into that formula. That formula says 1 over b, which happens to be pi, minus a, which happens to be 0. Remember, this is your a and this is your b, times the integral from a to b of the function we're trying to find the actual average of. Okay, so all we're going to do is apply the fundamental theorem of calculus, which first says to take the antiderivative. The antiderivative sine of x gets us negative cosine x. And then we're going to evaluate from 0 to pi. Okay. So I'm just going to bring that 1 over pi, bring it down, and then we're going to evaluate our fundamental theorem of calculus. So negative cosine of x, sorry, not negative cosine of x, let's actually plug in the values, minus a negative cosine of 0. Let's do some calculations. Really this is just 1 over pi It really doesn't want to work today. Let's see if I can get it to work. Okay. 1 over pi, negative cosine of pi. Well, cosine of pi is -1, and a negative 1 makes it a positive 1. Minus a negative makes it a plus, and that's also 1. So when we do this calculation, we get 2 over pi. And that right there represents our average value. Okay. If you want to try the next one on your own, go ahead and stop the video. If you want to just do it along with me, go ahead and continue the video. Okay, again, we're trying to find the average value. So if I want to find the average value of this particular function, here's my a, here's my b. All I'm doing is plugging into the formula. So 1 over b minus a, integral from a to b of the function that we're finding the average of. So 1/2, we're going to simplify that, and then we're going to take the integral. The integral of 6x squared gives us 2x cubed, and we're going to evaluate from 1 to 3. Remember, we're adding 1 to our exponent and dividing by that new exponent, so when we add 1 to 2, right there, we get 3, and when we divide by 3, that 6 over 3 reduces to 2. So that's how I got that. So now all I'm doing is plugging in. we're taking our top limit and plugging in, subtracting out the bottom limit. Here's my parentheses. And I have a double parentheses there. That's terrible. Okay, now let's do some calculations. So 3 cubed is 27. 27 times 2 gives us 54. Minus 2, which gives us 52 over 2 when I multiply that, which simplifies down to 26. Okay, so the average value. If you would like, you can try the two problems on the back. Two problems on the back come from actual FRQs, and we'll kind of go over those first thing in class tomorrow. Okay, if you have any questions, come in and see me.